Hello, this is question 15 on your June 2019 paper 1 from AQA. And you have a parametric equations question. So you have at time t hours after high tide, the height h in meters is given by this expression, and the velocity in knots of the tidal flow is given by this expression. High tides and low tides occur when velocity is 0, and high tide occurs at 2 a.m. Use the model to find the height of this high tide. So we say the high tide is going to happen, so we are measuring the time after a high tide, which means that a high tide is happening when t is 0, yeah, because we are starting measuring with a high tide. The way of finding the height when the tide is high is just substituting here t by 0. Yeah, because we are starting to measure when t is 0. So when t is 0, I have that h is 3 minus 2 root cubed of 0 minus 3 minus 3. Yeah, and this is going to be 5.8844 something else. I'm going to round, they don't say anything, so 5.88 meters to 3 significant figures. Yeah. So that's the first part. Then they say, find the time of the first low tide after 2 a.m. So we know the velocity is 0. Velocity is 0 for the high tide and low tide. So if we make velocity 0 here, we are going to find the time when that happens. So we are going to make velocity equal 0. So I have 0 is 4 minus 2t divided by 3 minus 2 squared, which means that 2t divided by 3 minus 2 squared is 4. So I have two options, 2t divided by 3 minus 2 equals 2, and 2t divided by 3 minus 2 equals minus 2. When this happens, I have 2t divided by 3 is 4, which means that t is 6. When I do this one, I have the 2t divided by 3 is 0, which means t is 0. So this is telling us velocity is max is 0 when t is 0, so at the beginning, because I have a high tide, and then 6 hours after, which means my low tide is going to happen when t is 6. And to find the time is going to be 6 hours after 2 a.m. So the time is going to be 8 hours after 2 a.m. So, sorry, 8 hours, no, 6 hours. So it's going to happen at 8 a.m. Yeah. Then it says, find the height of this low tide. So we know when it happens, we know t is 6, not 8. Yeah, so 8 is the time of the day when it happens, but the time is 6 hours after we start counting the time. So to find the height, we are just going to substitute 6 in our equation for the height. So the height is this equation here. So I have 3 minus, so I'm going to write this. So 3 minus 2 cube root of 6 minus 3. And this is, just with the calculator, 0.1155. We can round again to 3 significant figures, so 0.116 meters. That's the next part. Then for B, it says, use the model to find the height of the tide when it's flowing with maximum velocity. So the tide should be doing something like this. So it's going up and down. We start with t. When t is 0, we have a high tide. When t is 6, we have a low tide. So velocity is maximum here, and velocity is, sorry, it's 0 here and here. And this expression for the velocity is a quadratic, and the roots are in 0 and 6. So this expression is 0 for t and 6. So we have a quadratic and upside down quadratic. So my in 0 and 6. So I have something like this. This is 0 and this is 6. And you know the quadratic is symmetrical, so the maximum is going to happen when t is 3. That's a way of thinking. Or if not, you can see that the quadratic is in the complete the square form. So remember, I find my maximum or my minimum when I make this equal to 0. Yeah? When this is 0, t is 3. And the other possibility, if you don't realize that, is just derivating. So I can just derivate this expression and make it equal to 0, and again you get t equal 3. Yeah. So the thing is that maximum velocity, so maximum velocity happens when t is 3 hours. Yeah, midpoint between the 0 and the 6. And just to find the height, not the maximum height, that won't be the maximum height, but the height, we are just going to substitute t equal 3 in the expression for the height. So we have that the height is 3 minus cube root of 3 minus 3. I have a 2 here, no? I think. Yeah, I have a 2 there. This is 0, and maximum, the height there is 3 meters. Yeah, and that's how we find it. So it's just remember you are finding the midpoint or the maximum point of a quadratic. So you find the time that happens and then substitute in the height. Comment on the validity of the model. So one of the things that you have to notice is that the height of the tide must be periodic. So it's going up and down. And this function is not periodic. So when t increases, so when the time passes, this is going to increase. So I'm going to subtract something bigger and bigger, which means the height is going to go down and down and down. This is becoming smaller and it will be negative and more negative. So this is going to be valid for this bit, but then after here, with my model, the height will carry on going down while it should go up. Yeah, so I should have here a sine or a cos or a trigonometric function that is periodic or something like that, but this function is going to go down. So I think you have to comment something like after 6 hours, the height still decreases instead of increased again. Yeah, so the height still decreases instead of going up, instead of increasing. Something like this. Yeah, so it's not periodic. You can comment something that is the function is not periodic, so after the 6 hours is just carry on decreasing. Yeah, and that's all with this question.